So I wanted to talk today about data, all about the data, and continuously improving your machine learning models the data-centric way. So there's a couple of topics that we want to cover in the next hour and a half. So production data and ML system challenges, we'll start with that. An overview of WhyLogs and WhyLabs, AI observability platform. Then the bulk of this session will be kind of split between an activity, so detecting some data change and data issues for both retail data, but then I have an audible if we want to do some natural language processing data. And then the rest of the time will be, so there'll be a brief intro to kind of some data-centric AI principles that are really relevant here at WhyLabs, and then discussion. And I want quite a bit of discussion. So what I'm going to do, I guess people are trickling in. So what I think I'll do is the first section on production data and ML system challenges. And then I want to pass the mic around and just get a feel for the room and see where everyone is at and what they're interested in. So maybe I'll start with the first section just so people can trickle in. All right, production data and ML system challenges. So you'll notice that I'm going to just do a lot of interacting with the group. You've heard that I do a lot of teaching, and so I am definitely willing to stand here and stare at you until someone raises their hand. I guess the question is, how many of you would, of the two options, maybe someone who does production, machine learning, or data science, or works with production systems, versus someone who does something more like research or works in a, let's say, less dynamic environment. How many of you work on or with a production data or machine learning system right now? Awesome, cool. Question for those folks, how many of you work on streaming data? So now you have real-time data that's coming in, maybe in a Kafka stream, maybe some other way. Yeah, awesome. Cool. So the rest of you are working on batch data. Can I ask how many of you collect that batch data, or like the way you interact with that batch data is from a database? It could be a relational database. It could be like NoSQL or something like that. Okay. And how many of you work with batch data that comes out of some sort of blob storage or files? Like maybe you have, if you work with images, perhaps you may have like just folders of images in places or things like that. Okay, cool, awesome, great. Well, for the many of you who've worked on some production systems, there are lots of issues that you can encounter in working on this. And as someone who started out very like math and statistics, half of my life is research, where I have beautiful toy data sets that still give me problems, but different problems. Moving over to production data, when I started working at Amazon and now at WhyLabs, presents a number of problems and things that can go wrong. So I won't read this list. That would be the rest of this hour and a half. But there's things like you can set up a system and the environment, your production environment, is set up differently, has different settings than your experiment environment, and that may affect things. You may have deployed a different model version than you expected that you did. You may have things like computational instability, but then there's lots of other things. So you've pre-processed your data one way when you were training your model and doing your experimentation, but then after let's say your data scientist did that pre-processing of raw data to do the experimentation, they've trained a model. The model has had, high enough accuracy or performance metrics that you're pleased with. You get the okay for that. And then data engineers or some other group does the processing of the production data. So that's a different group. And likely there may be like mismatches between the way that the data scientists pre-processed and the way that the data engineers pre-process the data. This is a very common one. Things like correlation with protected features. So this is related to fairness. So when we say protected, we mean kind of legally protected, things like race, gender, that sort of thing. You may have like a surge of missing values. So maybe the data that you pulled out to train your model on, it's nice and clean, you have minimal missing values, but then when you put this in production, there's optional data or there's data that's missing on occasion. So the proportion of missing values is much higher in production. Many others, I'm just kind of picking random ones in here, but drift, so data drift, concept drift, in your inputs and outputs of the data, extreme like out of distribution queries you may have. So some customer basically has data or has a query for your machine learning model that is just far outside of what you expected to see. And then of course shifts in behavior, right? Anyone who had a model running in early March 2020 may have had a huge effect on that model and customer behavior because of the COVID-19. Okay, so one interesting thing here, and as a statistician, I'm required to say, or at least it'd feel bad to not say, that I can't speak to the sampling strategy that I used to pick all of these things. But my next point is that a lot of the issues that you run into is related to the data itself. So there's issues related to the environment or the code on the left, but a lot of the issues that you see are problems of the distribution of the data that you've had, the presence of it, that sort of stuff, even when they kind of present themselves as outperformance of the model or outputs from the model. Okay, so what are some typical questions that an organization facing data issues may ask? You may ask a question like, what is the distribution of this feature? So a feature for your machine learning model is like one column in your data set. I want to know, how is this distributed? How is this distributed today versus yesterday? Then should I be worried about data drift? So what you'll see over time is that maybe the distribution of data that you've seen looks differently today than it did last year. And for some places, this really matters. Even a tiny change in that distribution will affect the outputs of your model greatly and thus affect your performance. And then for other features, that may not be the case, right? This data drift may not have the same effects or may have just wildly different effects than what you expected. Is the quality of my data degrading? So especially if you're using some sort of automatic process, you may do some work to clean or improve the data. Is that still true today as it was when you programmed it? And then which data providers are supplying bad data? So so one thing you'll see is I talk about monitoring a lot in this talk, but there's kind of monitoring and observability. And many people will give different definitions for what those things are. Many people will use them synonymously. I should never use that word in a talk. I always fail. But I'll say that my definitions are this. Monitoring is very much about kind of giving alerts, so tracking metrics over time and alerting you to values of those metrics that seem extreme or important to you. Observability is about doing this checking, collecting this data in multiple places within your data pipeline, within your system, so that not only can I do monitoring on the values that are coming out, but I have some sense of where things are going wrong. So to have observability in a system means to have kind of multiple probes into that system so that I understand where things are going wrong and can start down the debugging process. All right. I think before we get here, I think this is a good time to stop. We seem to be more stable on people walking in. So Kelsey, could you maybe share around the mic? And what I would love to hear from everyone is what your name is, what what brought you to this session. And then if any question that we see on this page or any other questions that keep you up at night that you wonder how to solve for your use cases. Yeah, you want to maybe just pick that table in the back nearest you.
Hello? Okay.
Hello, everyone. My name is Yusa. I'm a data scientist from Statistic Canada. So why I'm joining this workshop is that our group is also facing the problem of, validating the data drift of whether this is, variance in this data or the model is biased somehow along the time passed by. So, that's one of our concerns. So that's why I joined.
Great.
Hello, everyone. So my name is Samara. So the reason why I joined this session is because so I'm working as a machine learning engineer, and then one of my responsibilities is to prepare the data better for the data science team to train their model. So that's why I joined the session, to learn how the best practice for prepare the data for the data scientists.
Great, thank you.
Hi everyone, my name is David. I work as a data consultant at Beam Data, and I've mainly attended this conference and specifically this workshop to learn about data drift and data degradation.
Hi, my name is Alan Garcia, and I'm a ML engineer with Procter & Gamble. And similarly, I also wanted to learn about data drift and best practices.
Awesome.
Hi, my name is Shaofang. So I'm from Scotiabank. I work in the credit risk modeling team. So the reason why I joined this is because we were also dealing with a lot of data issues in our work life. So we just want to learn a bit more about how we should be able to monitor the model and also the data that we use.
Hello, my name is Bintao Li. Actually, I'm volunteer in this conference, but now I'm free, so I chose this workshop to know more about data.
Cool.
Hi, I'm Farshid, and I'm working as data scientist with StreamML, and I joined this workshop just because I found the topic generally interesting. Yeah.
Perfect.
Hi, my name is Shardul. I'm a solutions engineer with Loblaw. We're kind of in the process of implementing feature stores for some of our data science teams. So I was just curious if there's any gotchas that we're missing, or just getting information on the topic.
Hi, I'm Munaf. I'm a machine learning engineer with Munich Re. We work with a lot of financial sets, data sets, and so I was curious about training, retraining, of course, and seeing how we can sort of evaluate different versions of the same model. And so I thought this must be a good opportunity, of course, to learn from everyone's experiences and from your experiences. So that's why I'm here.
Awesome. Cool. Yeah, we'll try to get to that toward the end. Yeah.
Hi, my name is Chris. I'm a data scientist with Wattpad. Just generally interested in the topic and the problems people are having and possible solutions and best practices.
Hi, my name is David, data scientist at Scotiabank. We just started implementing a data drift in our models, and it's already been super helpful. So I'm just curious to learn more about the topic and see other ways to do it.
Great.
Hi, I'm Arjun. I'm a data scientist and also manage data scientists at RBC. I'm more interested in how we do this. I think intuitively we know what to do, but I'm more interested in how we actually do this efficiently and at scale.
Yeah, all about that. Great.
Hi, I'm John Warner. I'm a data scientist at Delta Airlines. Sort of similar to everybody else said, we're slowly but surely trying to implement some actual guardrails around models in production and figuring out monitoring when to retrain, data drift, things like that. And so it would be nice if somebody told me what to do.
Awesome. Cool.
Hi, I'm Subra, and I'm a computer vision engineer, and I'm here to learn more about the different data issues that somebody can face while developing the models and retraining them, and how to mitigate those.
Hello, I'm Patrick, also a data scientist at Viva Systems, and yeah, same idea. I just want to kind of learn more about data drift and what can be done about it to mediate it.
Hi, I'm Shrishti. I'm from Vermont Energy. So we've been looking into, I guess, using features and trying to version those, but we also wanted to have a dashboard that could, I guess, display a whole bunch of metrics about our data so we can better understand where to improve it and make better use of it.
Great. Awesome.
My name is Karan. I'm a product manager on the ML platform team at Workday. I'm attending the session today because we're trying to connect the notion of data observability with the framework we're trying to build out for model observability and monitoring. Yeah.
Great. Awesome.
Hi, my name is Sumto, and I'm with the AI model risk team at RBC. So we work with a ton of models, and I'm here to get best practices for improving model performance from the data.
Cool.
Yeah. So my name is Prabjot Singh, and I work with Samtos. We work at the model risk management team at RBC, and we are here to learn if there are some suites of tests we can use related to the data for our validation.
Great.
Hi, I'm Zain. I also work at RBC, work with Prabjot and Samto. They've said everything, so I'm going to pass it on to someone else.
Perfect.
Hey, I'm Graham. I'm an ML engineer at a startup and a grad student researcher, and I'm interested in drift topics and updating NLP models.
Cool.
Hi, I am Mahsa. I'm working as a data scientist on a fraud detection project, and I'm facing all of the issues here, and we are in the phase of continuously improving the model, so I'm interested to know what other workarounds are and what are the best practices.
Cool.
Hi, Iman. MLOps team lead and XC.com as Masa, and we are dealing with continuous improvements, model drifting, and feedback loop, all the relative topics, and we're interested to hear the talk.
Cool.
Hi, I'm Mike. I'm a senior data scientist in Grundfos, a manufacturing company. We get a lot of our data from third parties and working with a lot of models that feed into control loops, so it's very important for us to understand and validate data and drifts and such.
Yeah,
so I'm interested
absolutely.
to understand these practices.
Cool. Yeah.
Hi, everyone. I'm Alan. I'm a software engineer in Replica Analytics, a very small startup in Ottawa. As a motivation to join this is I work very closely with our data scientist team. I'm looking for the new ideas and collecting information to solve our challenge data science problem. Thank you.
Cool.
I'm Harry from Raptor Maps, data platform engineer. We're currently building a data platform to ingest time series data that we're also using to reconstruct events from our transactional data. So I'm definitely curious about the versioning side of that because we just created a pretty large data set. Now we have a lot of feedback from product that we need to account for.
Yeah.
Hello, I'm Matthew. I'm also from Raptor Maps. Work with a lot of images, geospatial data. I think I've been really curious about how, observability and model explainability during your experimentation phase, how that can drive iteration on your data sets, and setting up a good system to do that. And yeah.
Sounds good.
Hi, I'm Richard from Medable. I'm the ML Ops platform architect. I'm here to learn how handling of the data drift as well as bad data cleaning up.
Sounds good.
Hi, my name is Vatsal. I'm a co-founder and CTO at a company called Speak AI. Volunteering the conference and also attending to understand how can I improve the pipeline and best practices for my team.
Cool.
Hi, is it speaking? Is it?
I think it's pretty close. Pull it a little closer to you.
Closer? Oh,
Yeah.
there we go. I'm Marnie Landon. My initials are ML. And I'm here to introduce the speaker, but I work in legal tech, and the data is a little bit different because of the precision that's required. And I'm just here to learn best practices and see the state of the art, the research, and so on. Thank you.
Hi, my name's Ben Baker from Family Search. Yeah, just here to learn about some best practices around some of the data issues we're having, trying to figure out how to improve.
Hi, my name is Luisa. I am a machine learning engineer in Definite Insurance. We have been doing a lot of monitoring, but not a lot of observability, and this is what I want to see on that on today.
Hi, I'm Carson. I'm an ML engineer at Meadow, which is a small AI for ultrasound company in Edmonton. And I'm interested in this talk because we have a lot of messy data, so often working with good data from GE and Philips machines, but wanting to do more point of care handheld, so data quality is pretty variable, and that affects a lot of our models.
Awesome. Thank you for going through this. I think it's super important to have like a discussion-based workshop, and I find that introductions are really helpful for people to know other people in the room, people at your table. And hopefully this does encourage you to speak up. I'm going to continue to ask you questions. We won't go around the room like that anymore, but hopefully you do speak up and we can kind of shift toward the topics that are of interest to you as we work toward the discussion. Okay, so this is another thing that I learned when I started working on production models, is that like, you can have production machine learning data, and unlike maybe all of the tutorials or classes or even research projects in my case that you've done, you may not be ready for the volume, how dynamic the data may be because it's changing, your features are changing. And increasingly, it may be actually like streaming in the form of streaming data. So you have data that's not just a big data set sitting somewhere. It's actually, for example, live data that's coming in from one of your endpoints. And so there's complexities there. The main complexities that I want to talk about right here at the beginning is scale and streaming data. So how do you analyze a bunch of data, even if it's not streaming, but especially if it is? There has to be some tricks that you take on to be able to group this in a way that makes analysis feasible for a data scientist. And some practices that people use are sampling techniques. So there's very simple sampling techniques. These pictures, I think the way that what I was intending on the left is sampling by machine. So let's say you have a distributed system. You may have multiple machines that's running the same model. Likely if you're going to collect metrics there, what you're doing is you're calculating those metrics like one per machine. Another way you might slice things is by any of your features. So this is a feature city, Seattle, Austin, San Francisco. Normally I change the middle one to the city that I'm in, so I apologize, Toronto. I did not change my slide. Last time I gave this, I was in Austin. So slicing data in a way that's kind of similar to the one on the left too, but into segments based on either time, so we could do this by date, or characteristics like one of the features, is something that happens quite a bit before conducting analysis when you're handling this sort of data. All right, so now we're going to talk in detail about, not too much detail though, but talk in detail about three approaches that I see teams take on, and this is both in-house, if you're trying to build some sort of monitoring or observability tool in-house, and maybe you don't even call it a monitoring or observability tool, because it may be things just like we have this data or like this this metric that we need to report to our business stakeholders. How do we calculate that? Well, this is kind of the first step toward monitoring. Maybe you don't have alerts on it. Maybe you're gonna, watch it every day or something like that, or every month. But they all kind of apply similarly. So the three approaches that I want to talk about, the first is random sampling. So this is, you have a lot of data. So let's say we're in the case that you have a ton of data, right? We can't eyeball the data. That's at least the case for all of us at this point. How do I store some amount of data that can fit on my machine and do some further analysis? So one way to do this is, so if you have a production system that has more data than you're willing to put on your machine or able to put on your machine, what you might do is take a random sample. And by that, random, it's a little bit of an overloaded term. We'll talk mostly about like a uniform random sample, so just of the data points coming by, I want to collect 1% of them. But there's different ways you can sample, so you can do a stratified sample, things like this. Okay. The second way, the second two ways are both data profiling techniques, and we'll talk about that in a bit. But the middle one is using scalar metrics. So these are the metrics that we're all familiar with. They're things like the median and the mean and the standard deviation of the data that you've seen, and maybe if you have performance metrics, you can collect things like accuracy, those sorts of things. But all of these are often a single number or a very, very simple kind of fraction situation. Then the last one is what we do here at WhyLabs, and this is using data sketch-based metrics. So these are advanced data structures and algorithms that have been built mostly for databases at the beginning, a very popular kind of theoretical computer science topic about collecting and summarizing data. And the cool things about these data structures is that they are very well tested. They often have things like error bounds, and they're meant to be very efficient at collecting information about the data that it's seen in a way that is rigorous, in the way that we can talk about how that was done, and recover a lot of information. So we'll talk about what's in those, but let's start with random sampling. So what I want to do is give kind of pros and cons of each approach. There are pros and cons, certainly, to random sampling of the data. So we have an example here. Let's say there's 198 million rows for this day. We want to sample maybe some subset of that, so let's say about 500,000 rows, and store that in a CSV file or a Parquet file or whatever you want to store it in. And this is just kind of CSV format, so pretty standard. What are the benefits of taking on this approach? Well, one is that it's in the same format as the original data. So if you keep a sample of your data somewhere, a data scientist can pick up the file from your sample, and they know what to do with it because this is, a form that they've seen before. And this is really valuable, especially as a kind of a first approach to starting to measure things like drift and things like that. It's highly flexible. We're not getting rid of any information, we are getting rid of information. We're only keeping 1% of the sample, but we're not choosing which features to get rid of or things like that. So all of the analyses that you could have done on the large data set, but maybe don't have the computational power or don't have the space for, you can run on this smaller sample, and that's really cool. It theoretically could work for batch or streaming. Depends on what your setup is like, and we can talk more about setups in a little bit, kind of in the discussion section. And it's mergeable. So we will talk about the value of mergeability a little bit later, but if I had a random sample from yesterday and I have a random sample of today, and let's say the last 5 days of this week, and I want to get some weekly random sample, all I have to do is add them together. That's easily mergeable. It's not always the case, so we'll see some examples where it's not the case. Cons. So there are poor estimates on the tail of your distribution or outliers, right? So if I care about something that only happens, 0.5% of the time, the probability that I happen to catch that in my sample is low. And maybe 0.5% is pretty large. That's not always the case. It may be even more rare than that. So when you start to think about the tail of your distribution, then you may be missing these in your random sample. And you might catch a couple, which is sometimes nice for some debugging cases, but you don't have a great picture of how often this rare event happens. And unfortunately, these rare events are the things that we care about. These are the things that, there's other things that can break our system, certainly. There's lots of ways these things can go wrong. But for example, if I had, 0.5% of the time, the total tax in this column here is a negative number, I may not catch too many examples of that. Poor precision. So this is based on what percentage of your data you can examine, but even things like standard things like calculating the mean or median. Let's stick with median. The median calculation on a sample of data is not great. You have to do quite a bit of work to feel confident that this is a precise estimate. And then a huge con, and the reason that there's lots of people who just can't even do this, is that it is a high storage cost. You're still storing, in my example here, 500,000 data points. And so if storage was your concern this entire time for not storing the whole amount, you may have the same problems for storage if you decide to store a sample. Okay, so data profiling. How many of you have heard the term data profiling? I found that if you asked me 3 years ago, I would say I hadn't, and it seems like a small number of people. Okay, so data profiling is the act of kind of reviewing and analyzing data sets to understand their structure and information. So data profiles can include things like descriptive statistics, identify different data structures, do kind of categorization and creating descriptions. So this is really in the case that you have kind of more complex data types. You can do data quality examinations, so things like defining constraints. In our world, that's what we call those, and more. And so there's lots of tools out here that do some form of data profiling, and they all kind of give different things. So some are visualization focused, some do metrics, ours is a different type. But I'm going to kind of make a very simple version of this and talk about scalar metrics only. And so these are tools that create, so let's say you have some data set, this runs through, and it'll grab things like the mean, the standard deviation, certain quantiles, accuracy, precision, recall. And the pro of using scalar metrics, so if we think about a larger system now, and flip maybe back to this, what you would do is calculate all of those metrics for the Seattle group, calculate all those metrics for the Austin group and the San Francisco group, and now we have them. And then you can also do that over time. So you can have them over time as well. All right. So what are the pros and the benefits of doing the scalar metrics approach as opposed to the sampling approach? So one is that you have fast access to key metrics. If you store a sample, what this means, and you're not storing these key metrics somewhere, what that means is that when I want to go figure out what the median is, or the 95th quantile for my feature in the data set, I need to load that data up and calculate that. And calculating that probably doesn't take very long, but getting the data, moving it to a place that you have compute from your storage and calculating that is a process. It's low storage size, right? So unlike the sample of data where we're storing 500,000 rows, we're just storing a list of metrics and like a single scalar value, pretty small. These are the actual metrics on the batch of data. So what we'll see in a bit, so we've already seen for sampling that when I talked about precision, that these are estimates. of these measures, right, for the whole data set, because we don't have the whole data set. We only have 1% of it, so it's an estimate. But if we're actually running these metrics and calculating them like in real time, let's say on your machine, for all of the data that we've seen today, this is going to be the actual true value for today's batch. What are some of the negatives? So the big negative is that it requires metric pre-selection. You need to know before you've done this calculation, before you delete the data off of your machine, exactly what metrics you're going to need, because you're not going to get that data back. And so that's a problem. And if you're able to hone in really well on what metrics you need, you can pre-select some good metrics for yourself. But there's often cases where someone asks, oh, well, maybe instead of precision and recall, now I want area under the ROC curve. How do you calculate that now that it's gone? It's really difficult to. And then it's non-mergeable. People often forget this when they start to do scalar metric-based profiling techniques, that they'll say, okay, well, every day I'll calculate accuracy, and I see a nice line of accuracy over time, and that's great. But then what happens is I want to now look at multiple machines. Turns out I had 8 machines running with the same model. They gave different accuracy metrics. I need to know how to combine them correctly. And this gets more and more complicated depending on the metric that you have. Some metrics, easily add together, or you just have to weigh it. But there are many metrics where they're just not mergeable in a very easy way at all. So for example, one that comes to mind is for cardinality. If you want a list of, a count of, let's say, the unique values that I've seen. So if I look back at my sample data, just so I can see the data in front of me, let's say this product subcategory here. So it's electronics in this example, or personal appliances. I don't know which one. But either way, let's say I just wanted to keep a count of how many unique product categories I see at a time. And then let's say I did that on each of my different machines. And now I want to know how many unique product categories did I see in this week. I can't calculate that. They're not mergeable because I don't have the categories. I just have the count. There's no way to know how much overlap there is between any two batches. And this makes it really difficult. And I just want to emphasize that one because I think the non-mergeable metrics, the scalar metrics approach is kind of the first thing that maybe a machine learning infrastructure team who's building this in-house will go toward. They'll say, okay, well, we'll calculate this per day. This is great. You get the nice line. This is great. If you use a APM company, so someone who's meant for monitoring but not necessarily meant to monitor machine learning data, then you can also calculate this metric, send it over to New Relic or Datadog or something like that. And that's great because it probably builds into an existing system that you already have for engineering. But then where it really comes to bite you as far as machine learning data and data is that when you go back to combine them, they can often be these really complex things that don't merge. Okay, and so that is pretty much what this slide is about. But here's some examples of reasons that is not sufficient for root causing your production system. So a lot of these I've mentioned through this, but they really come back to mergeability. So can I combine multiple together? And especially for cases like cardinality or sets of data and distribution drift. There's certainly things like error bounds. When you get asked, well, okay, cool, you calculated this metric, how likely, how far is it off? What's the precision of this metric? Then being able to calculate those is very difficult. Rank is also an interesting aspect. And data mergeability is critical for observing these kind of long tail and rare events. So everything I said about it being hard to merge these different batches goes even more for when you're looking at the tail of our distribution. So you need to have something that's thoughtful. Okay, so then I'll go on to our third solution, the one that we came to over at WhyLabs, which is sketch-based data profiling. So again, data sketches is a field out of kind of the database community and now the probabilistic algorithms community. And there are lots of benefits to using sketch-based data profiling, often combined with scalar metrics as well. So you have the same fast access to key metrics that you had to the scalar profiling. But the thing you get that you didn't have for scalar is you have high flexibility. The more complex of the data structure that you're able to collect during this profiling process, the more you're able to recover as far as new metrics without having to pre-register them. And low memory and storage size, they're mergeable, so I mentioned that quite a bit. And they're built on kind of an academic community that's peer-reviewed. And I won't talk about peer review as an academic. I don't think that's great either. But I think it's important to use kind of techniques that have been used elsewhere, right? Like not something that necessarily you're putting together and doing the math on the back of an envelope for, but we have great ideas about what's the error tolerance of this technique. Like how likely is this to have hit the worst case? Some downsides of sketch-based data profiling is even though you have this flexibility above the scalar examples, there's still some things that will require pre-selection. It's not a promise that you can calculate any conceivable metric on top of a sketch. There's still some matching that has to happen. And that is what I do all day long. And then the other con is that there is underlying algorithm complexity. So you have to understand these data sketches. You have to be able to implement them or at least know how to use them. And that just takes costs, especially if you're trying to build something in-house. It can be really complex. All right, but the really cool thing about sketch-based data profiling is that you can get really advanced analysis that you couldn't really get from scalar metrics. So you get error bounds, you can calculate things like feature importance, you can do outlier detection in surrogate models to kind of represent your model, and this is really cool. Okay, I am going to just take a breath here. So we've done the three comparison. Any questions on what I just presented? Any technique that I missed? I didn't include just ignore it, although I did that for a while. Yeah. What does it do? Yeah. So I didn't have the slides here. Let's toward the end I can pull up my other deck and we can talk about sketches. At the high level, I'll say the way that sketching works are that they are different, kind of custom for every task algorithms that are combined with some data structure that normally does a bit of complex sampling combined with like tracking of error bounds as you're streaming through data. So for example, in the cardinality case, you use something like hyperlog-log, and that technique is more of a hashing technique. So what it does is it keeps a hash of the unique values in addition to a count, in addition to some metrics about the error. And so that way when you see new values, it adds a hash for that. So that way when you want to combine them, it can check the hash and let you know how many overlap. But it's meant to be efficient, so it's not like a perfect hash even. That's why they have these error estimates so that like they can do this as efficiently as possible and give you an estimate of how many are overlapping. So that's one. Hashing is one common technique you'll see in sketches. Another is like sampling with some metric on how to like multiply it and keep track of error. There's a couple of like tree-based methods inside of it. Cool. All right, so I'm going to go pretty quickly through this. This is the overview of WhyLogs and WhyLabs AI observability platform. And so when we think about monitoring a system, we think that there's a couple of things that you want to do, but we've really kind of based this off of an APM company, something like Datadog and the way that we might think about monitoring there. And that looks quite different from other approaches for monitoring. So when I've seen in-house monitoring solutions, you might do something like store all of this data or store these scalar metrics that I talked about, this profile, This looks quite different. So what you'd want to do is you want something lightweight that you're able to put in moving data, like next to moving data, everywhere possible. And this is what enables this like observability. As I said, you want multiple probes into your system. So you want to maybe put something in as it's going into your feature store, as it's coming out of your feature store, while you're doing live inference, so on your model, while you're doing, so live inference being like streaming data. If you have a different model or different system that does batch inference, maybe you have a like weekly job for all of your customers, you want to be able to capture these metrics there, as well as offline. So while you're training your model, every time you train a new model, it depends on how much your data set is changing, but if there's going to be a change to your data set, or if there's a possibility that there's a change to your data set, you want to capture this here. And the way that we think about data at WhyLabs is that the outputs to your model is a different data point. So there's many ways you can think about tracking the outputs of your model, but effectively it is data. So we kind of treat, I would say the whylogs is really operating on data. There's just specific metrics that are more related to models. But once you have something that's lightweight, like an agent that you see at APM companies, that you can put in these different environments, now you're really starting to get probes across your system in many places. And once you have that agent, what we want to do then is use these sketch-based summarization techniques so that all we're collecting is summary data. And we're taking all of the data you've seen and reducing it down to these data structures and these metrics. And then you can do a lot of things with this. So I'll talk a little bit about this next. So this here, this little orange AI telemetry square, this is where we do this algorithms, these sketch techniques. And we have open sourced our version of this. So this is whylogs. And it's really great. So you can go to bit.ly whylogs or github.com/whylabs/whylogs. But what you'll see here is that it is built on top of Apache data sketches and has a number of sketching techniques. And this really allows it to be efficient, customizable. We've put a lot of work into making the way that you build on top of those sketches customizable, mergeable, of course, works for online or streaming data as well as batch data, and then statistically sound. And so setting up with an agent like this, our view is that you should log or profile or just collect information about regularly both your training data and your production data. So for your production data, this might be batch data, this might be streaming data. You want to collect this on a very regular cadence, and it depends on how much this data is about to change. It depends on how your system is used. But the example that I give here is daily. So if I collect this data in daily batches, I can very easily uncover the aggregate accuracy or mean or something over the day. And these little orange squares are the labels. So maybe you have some validation data or test data. My coloring is a little off backwards here because that would be my training data, but that's okay. But it's meant to be the labels. And then on the other end, the thing that it took us a while to realize because we were so focused on how do we get our production system working? How do we get observability and visibility into our production system? We realized that you could also run the same profiling process on your training data sets and on other reference data. So often it's the training data set that you use to build your model. You want to do the same profiling on that because you want to be able to compare very easily all of the things that you had for the data that your model is built on. So for example, this is where drift comes in. I can measure drift a number of ways. I can think about drift over time, how much does yesterday's distribution compare to today's distribution. But if I'm thinking about the freshness of my model, I often want to think, how does the training data for the model that's in production right now compare to today's distribution that I ran on? And so that is something that was hard learned that we really need to push for customers and for ourselves to use profiling on training data sets. And often that is an important reference to kind of monitor against. All right. Yeah, I'll go forward. And so once you have these logs going, and we can talk about that more if you want, we have the WhyLabs AI Observability Platform. So this is a SaaS platform in which you can upload those very lightweight logs and get kind of all of the time series analysis and analysis of multiple profiles that's helpful for you to understand drift and things like that. So this is just meant to show kind of thinking about what information you can get with batches of data. And I think this is an important thing to think about as you're considering the system that you're building. So with a single group of data, let's say like your training data all in one pile, one group, you can calculate things. So you can profile this data to understand, to just document your data or store metrics about it. This is why whylogs is called whylogs, because you can use these profiles as a log for your data and store them somewhere and go back and look at them. Of course, with a single data set, you can do things like exploratory data analysis. It's a common thing to do. You can also do things like data unit testing. So some people mentioned this, things like coming up with constraints, knowing that the values in my FICO score row should never be above 850 or below, I don't know what the bottom FICO score is. Other things like this. But once you get 2 profiles, you can start to do more things. So you need 2 different data sets, 2 different distributions to measure drift. So that's a natural first thing that you're doing. You can do, so this is like an ad hoc, like whenever you choose to, comparison to some baseline distribution. But when you have 3 or more, and particularly when they have some temporal element to that, you can start to do monitoring over time and kind of time series analysis. And that's what our SaaS platform gives you. So in addition to that monitoring, notifications, depending on the settings that you have for it. So this is just a screenshot of this, and the monitoring settings, this is actually expanding fairly soon. We have a beta out about doing more for notifications and setting up your monitoring configurations so you can do that programmatically with an API, as well as more algorithms. Okay, so now I want to jump to our activity here, and I want to do a bit of a preview. So let me get out of my slide. Okay, this is the WhyLabs AI Observability Platform. And what you'll see here is a number of projects that I have with some data in it. They're at different times, so this is why they don't seem to all have data in them. But let's look at our model here. What we'll do, maybe we'll go through the demo instead and get a chance to look at the platform if my internet's working a little better in a bit. Okay, so we'll actually switch to the natural language processing demo. And what I wanted to do is just give an example to some customers about named entity recognition. How many of you are familiar with the concept of named entity recognition? Oh, wow, more than I expected. Awesome. Okay. So named entity recognition, for those who have not, is a task where you have some amount of text. You often see this on newspaper articles when you're doing tutorials or academic projects. And what you want to do is detect all of the proper nouns, essentially. So things like a name of a country, a name of a person, a name of a business, a date, those sorts of things. And those named entities, it's a classification problem. So for some word or even phrase, is this, an organization name? Is this a company? Is this so on and so forth, right? And this can be really helpful if you're doing something like document understanding or classifier, if you want to classify news articles based off of topic or based off of who's involved. that sort of thing. But what I want to show here is just kind of how you can think about setting up a project with whylogs and then sending that over to WhyLabs. And unfortunately, we're in an interesting time where we just released a couple of weeks ago, 2 weeks ago, our version 1.0.0 of whylogs, and the API has changed. So this is going to be, actually I should check, this is going to be the old API version, and then I can show you some new API changes, but we'll get the job done here. Okay, so what I want to do is, so often you have just a model, right? And it's important to realize that there's kind of two places that you may collect data for monitoring. One of those places is when your data is at rest. So this is often in a database somewhere. And the other place is when this data is on the move. So in the case of, you might be making predictions. And you have running code, and inside of that runtime, I want to do some work to send that data for monitoring or do work. And that's where whylogs runs. And because it's running often in people's critical path, like on the same code, on the same machine that they're doing their model calculations, their actual inference, it means that we're extra careful about things like the latency of this. We had a customer who had a latency requirement of like 13 milliseconds in the like simple case, and we're able to do that. We had a queue just to make sure that we're really not hurting them, but on average 13 milliseconds. But again, this depends on the type of data you have and the size of data that you have. So for our named entity recognition, that means we're going to have a model right here, and we want to, so we're going to run this model. We have some transformation that I want to do, and I just want to show that this code you already have, obviously much more complex than my model right here. I'm just using NLTK, but this transformation code is very simple and not necessary. All I'm really doing is renaming a couple of column names and making sure, like making a nice and clean data frame of the outputs that I want. And one thing to note for named entity recognition is that there's kind of 3 levels of output. So this is a really complex output because for named entity recognition, you take in text, then you often do, you might train embeddings. You might have word embeddings on this. I don't have word embeddings here, but you often have parts of speech. So the different parts of speech in language, is it a past participle? Is it a noun? Is it something else? I only know 2 parts of speech, by the way. And then you have your named entities. So all of these things, I just want to format cleanly, and then I'm going to simulate some model error. The reason that I'm simulating this here is because you should never make a demo and not realize you don't have labeled data until the end of making my demo, and I was too lazy to pick a different data set. So I'm just simulating some model error here. But okay, let's see what this looks like. So I have the input. So this is a raw document text from routers. This is kind of the first sentence is kind of the headline, and then you have the rest of the text. When I pass it into my simple named entity and parts of speech model, I get an output for this input that looks like this. So I get a file ID. This just happens to be where I pulled it from. A category. So this is just some metadata that you often have metadata with your models as well. And this can include things like version information. So or the location of the data or the URL on which you collected this data, this sort of stuff. And then I have a metric here that I pass in, which is the token count. So tokens and words are slightly different, but I'm going to use them interchangeably in this case. So the tokens just means like the number of words in my model. Okay, my second set of inputs, or my outputs from the model are the parts of speech. So this is for every word or token, what is the part of speech? So is it a noun? Is it, I don't even know what a JJ is, these sorts of things. All right, and then lastly, as my output, I have a list of tuples of my named entities. So China is a country. We have organizations, which this did really well for. I'm proud of my model here because it saw that daily, we're talking about the China Daily, which is a newspaper, I assume, says, this is obviously wrong, so my model did not do well there. But these are other named entities that my model detected. Daily is also not a person, not a great model. Okay, so how does this get sent into whylogs? Well, the way that this has worked in the past is that you create a session. So if you've done any system setup, you might be familiar with the concept of a session. We want to start a session so that if we have any kind of state, we're keeping it inside of this session. And we give it information like the project name, the pipeline, and the cool thing about whylogs is that you can define different writers. So you may want something like a local writer. This will take the binary of this profile and put it on my machine once it's done running. But then we can have other writers. So writers that write to S3. We have a writer that works with ML Flow and makes it an artifact in ML Flow. And then we have the WhyLabs writer, which will, when I'm done with this, send this, upload this binary to the API, the WhyLabs API. Okay? And that's all I really, so I set up these sessions, and then all I have here is a loop that's going to add some information on it, and I'm kind of simulating a whole week of data here. So I'm just looping through, and I'm going to log the output of my model. So here's, let's see, so I do some, where's my model? Oh, it's inside of this. So here's my model that I'm running on a file. Then I'm going to transform that output just into the prettier form. Now I have these three separate data objects here. I'm going to add on my simulated performance data. And then the logging process is fairly simple. So we have a different log process for structured data. The cool thing about whylogs is that, and this kind of metrics, the sketch-based metrics approach is that we calculate data, or we calculate metrics with a fidelity that is high enough that we're able to calculate things for text and images. And the reason for that is that it's really difficult to profile an image or a set of images really well if we're just keeping raw numbers. But it's actually really effective to start profiling these things if we keep a histogram or a CDF of distributions for your image. So things like hog features or just the color histogram, things like that. These things are really important. So we have a separate log for this text, and then we log in our parts of speech data and our named entity data, and then log our metrics. And so I just run this, and this is an example of an output, one form of the output from whylogs. So this is a JSON form, so we can see it. The best version, of course, is the binary that we use protobuf to encode and decode. But you can see inside of a whylogs profile, we have things like, schema versions, session ID, timestamp, that sort of stuff. Any tags that we passed over. If I had more metadata, I'd pass it end up here. And then for each column in my data set, lots of different counters and metrics depending on the type of data that got passed to it. So in the case of token count, you can see, what type is it? We have type inference here, version 1.1. So version 0.0 is always inferred, but version 1, there's a lot of settings, so you're able to either infer or define explicitly what type it is. And that's helpful for speed reasons. It really helps performance to not infer if you really want the speed. We keep a count of the different types. So right here we see that all of the values that pass through, so of the 99 of them were integers. But in the case that maybe there's a couple of fractional values, this is really helpful because this is a data quality problem. This means that something happened where I got a fraction where it probably shouldn't be because this is supposed to be a count. And that is the type of information that you need to be tracking in order to see data quality issues. Okay, so because it's a numeric value, it has lots of the kind of standard metrics that you expect to see here: min, max, mean, standard deviation, some points on a histogram, and bins for this histogram, and unique counts and things like that with their estimates. But the cool thing, so even though this is JSON format and we obviously can't have an object, the cool thing about this is that I don't just have these quantiles that I've defined here. I have an object where I can query for any quantile that I want because I have a full CDF. And when I can also come out with error bounds for those. Okay, I won't go into detail of this, but these are the sorts of things that we have in addition to these kind of data structures. Okay, so visualizing. So there's multiple places we can visualize this. So if you want to do this in whylogs right off of the profile, we can use the profile viewer or the notebook profile viewer and see things like, so for example, for strings, what we find is one important thing to collect is certainly the string length and how that distributes over time. So for whatever reason, this is a pretty small amount of data sets. We can see that the medium string length, median, doesn't change too much, although it changes a little bit, but still around 1,000. But the distribution of string lengths widens. So if you see the 25 to 75th percentile and you see the 5th to 95th percentile, there's a big widening kind of in the 50 to 75 percentile, right? And these are the sorts of visualizations and things that you need to start monitoring, as well as the alerts that you can put on top. Other things, so unique values, again, having a tool that's able to merge multiple profiles together and calculate realistic unique values. You'll notice on this one, it's pretty small because this is a small data set that I pulled, but these are estimates. It's just that they're so small and Data Sketches works well in low values, so it stores the exact value up until it gets large enough to have to make estimates. So the estimates are really tight. It's bounded because they know that this is the exact value. Awesome. So let's just finish out the named entity recognition model. So what I did is I split this up into 3 projects, one to show the documents, one to show the parts of speech, and one to show the named entities. So let's look at the documents first. So what you'll see here is that we have 3 alerts. They tend to all be on token count here. And they're split into different types of alerts. So we have data integration alerts. This is about metrics that you'd want to collect about whether or not you're receiving data at all, right? So if I'm expecting data once an hour, or it's come normally once an hour, and we go an hour and a half without seeing data, we should get a data integration alert. Data quality alerts, these are things like if we had integers and all of a sudden there were a couple of fractional values, we want to collect things like that. Data drift, so this is mostly the distribution of your actual numbers, so kind of what we showed before. And performance, these are metrics that we have on performance, so the fake performance that I sent there, but these, F1 score, accuracy, that sort of stuff. Okay, so for a feature that I have here, token count, we'll go to the one with the alerts first. This is a little bit busy of a screen here, but what I want to show you is we see that distribution chart that we've seen inside of whylogs. We also see in yellow the max and min. And again, that's a cool thing about sketches that we have the exact max and the exact min. Not very hard to calculate that particular example, but just that these data structures already include these sorts of things. And then what we've included here is a distribution distance measure. So this is, I should check my settings here. So if I look at, we'll go right here. If I look at my settings, I have a learned threshold. So I'm asking WhyLabs to learn what metric to alert on, but my reference, instead of doing the training data here, I use a 7-day window. So it's saying, looking at the past 7 days, how different is today's distribution, so this date, compared to the 7 days before. And so these are all of the days that I uploaded, a small experiment. So the first day, of course, there's no distribution distance, there's nothing before it. But the days after that, you can see some measure of how different this distribution is from the distribution before. And we have time series analysis on this distribution distance. So you'll see at this point, we learned a threshold of 0.7 for the distribution distance, but it's further than we expected it to be, and so we have an alert here. And the distribution distance obviously grows here and is larger here than we would expect it to be. Okay, we have other alerts here. Oh no, we have 3 distribution distance ones here. Let's look at one more model and then we can be done with this. Let's look at the actual named entity recognition model, where we also have token count. I wonder, let's see what kind of alert that was. Okay, this is also distribution distance, so we won't talk too much about that. But maybe we'll look at the performance, so we can see things like the number of inputs relative to the number of outputs. So I didn't put the outputs in correctly here. So we have 0 outputs, but normally these things are matching. And if we see a difference between the number of lines of input versus how many have outputs, right? So things that weren't able to generate an output, we'd want an alert on that as well. Right now, this is always 0, so it's never problematic that when I see a difference here either. We have accuracy, we have confusion matrix, we have recall, FPR, precision, F1 score, this sort of stuff. Other things that I'll just point out while we're here that I don't have in this particular demo, and I won't have time for the retail demo, sadly. Segments, so we can decide to slice our data across any feature when we do that profiling, and so then we can dig into it for a particular slice of our data. We have things like a feed of alerts, so that we see running in here, monitor settings. I think the other thing I want to show is settings, notifications. So what I can do is I could have turned on Slack messages, and so I just pass in a Slack webhook for Slack, and decide if I want weekly messages or daily messages. Things like PagerDuty also pass in a webhook. I can pass in my email, so I can get an email at some frequency with these sorts of things. I'm going to, let's see here. I'm going to talk just about a little bit more about data-centric AI to wrap up, and then if we have any questions, we can go on from there. Okay, so we really think about data-centric AI, 2 principles from this. So data-centric AI is this sort of movement that has existed a while before the name has, but this thought that iterating on a model is something that academics do, but when you're in production, often what you want to iterate and improve and make improvements to your model, you're going to be considering the data that you have and the quality of your data. Okay. So these are 2 principles that I think about and I think is important to think about as you're building machine learning systems, especially production systems. So data iteration and continued data set development is just as important as model development. So what I was hoping to get to, but my timing was a bit off, is going through our example and actually updating our data set based off of the findings that we had from this monitor and seeing how our model improved and how we can think about our model by iterating on the data set. And the second one is that small, clean data sets have the potential to improve AI systems. So practices that involve kind of refining data sets, so looking through your profiles of the data, looking through the raw data itself to reduce label variance warrant further investigation because that's really helpful for us to train models on these more precise data sets. But there's kind of a caveat here, and that is that we are building systems for production. So we know that so we're able to train a model on any data that we choose. And often we see this kind of used when we augment data to train a model. So we augment data. So for example, if we have some images, we might take those images and rotate them and add that to our training data set, right? Because this makes our model more robust. And we can also do the opposite of that. So instead of adding a lot of variation to our data set, you may also clean your data set to improve it as well. So if you think about kind of Bayes' error, so this is like the theoretical minimum amount of error that you can have on your model. This might be really high if you have a messy data set. So if you have a data set where it has essentially the same input but different labels on it, that is going to be a problem for almost every machine learning model you're training. Not every single one, but almost every single one. And refining your data set during your training process, during your model building process, can be really important. And using tools like profiling and techniques like profiling and tools like whylogs can help you identify data quality issues. Okay, so I'm right at time, so I'm going to stop here for discussion and any questions. I guess I'll say that we have some swag. Kelsey has some swag in person if you're interested in any of these things, although I think we don't have the stress balls right now. We ran out of them yesterday. But there's so please do go and star the whylogs project. Check it out if you're interested. Feel free if you want to talk more about whylogs or have questions for me or others, go to the whylogs Slack. And if you want some swag, I think this is still going on. You can fill out this form and get some swag sent to you. All right. So with that, I'll leave it here and talk about any questions that you have. We didn't get a chance to talk through specific drift things, so I apologize, but we can do it now. Yeah. Yeah, great question. So yes, seasonal drift is really interesting because you have this problem, right? You have, you likely have something like some seasonal trend, maybe over the year, as you were saying. In January, it's low, whatever month it's high, this sort of stuff. But then you also have some overall trend, right? So you can't directly compare January 2022 to January 2021 because your business might have just grown in that time, right? Like the overall trend might matter. So the way that this works in kind of the whylog space, but I think in general, thinking about this for approaching your system, is that you want to collect this data at a granularity, maybe monthly, maybe weekly or daily, and you want to do some sort of trend decomposition. So we have trend decomposition models or ARIMA models work for kind of the time series aspect of this. What I find is I find that once you get to seasonal trends, you really need to have a model that's explicitly built for time series. And then also thinking about, we've personally run into a lot of things related to data quality issues with time series models. So you might have January data from last year and January data from this year, but there's some outliers. There's some days that your data was just bad. And that can really mess up these trends that you're estimating over time. And so one thing, if you're looking to build this yourself, I would say work on the data quality aspect first, maybe even having a simple model to get rid of outliers, and then do some sort of time series analysis. ARIMA, seasonal trend decomposition is really cool because you see a different line for the trend as opposed to the seasonal component, and then as well as the residuals.